Thank you guys for being here today. My name is Samir Aman. This is James Cooksey, Trisha Okello, Nader Armouche, and Taha Hussein. And with collaboration with ATEC, we are Waddell Designs. What we're tasked to do is we designed the Waddell Lights over here. Back in the 1970s, Theo Waddell created this classic light fixture that was a hit with the art community. It was featured at the Louvre in Paris. It's currently at the Museum of Modern Arts. Unfortunately, it didn't reach the same level of success with the consumers at that time because of two reasons. It lacked durability and it had poor packaging. Our goals for this project is to first redesign the Waddell Lights with modern components. We will also like to focus on expanding the durability while still staying true to the original design and aesthetics. And we want to create a product that's marketable and has the interest of a multitude of consumers.
When we picked our hardware, we had two things in mind: functionality and aesthetics. So, for example, we replaced the original design, which had a filament with LEDs. We accomplished this by using SMD LEDs, which were soldered together really closely, and they were wrapped with plastic coating, which had phosphorus to give us an even, uniform light. We also are using a microcontroller to accomplish all of our smart capabilities that we're planning on implementing, and a small factor as well. Another improvement we made is that the original had to be plugged into the power outlet, but we're going to replace it with rechargeable lithium-ion batteries. And with this setup, we should be able to get around 19 to 33 hours of power.
Now, in implementing this hardware, we ran into some limitations that we think we have overcome over this semester. For example, implementing many light sticks, LEDs in differing orientations wouldn't allow current to go through all of them at once. So our microcontroller provides rapid current switching so that they all appear on simultaneously. Getting the aesthetic was a huge issue we had to tackle. So we really think that our LED filaments will capture the same brightness and warmth that the original had, as well as not producing as much heat and improving the interactability. As far as the glass coating on the light sticks, we think that either blown glass or epoxy resin will give us the best refractive capabilities for the aesthetic look we're going for. As far as color changing capabilities, we looked into smart LEDs, but they had turned out to be too big, so we couldn't get that control, so we opted instead for a toggle switch on each rod such that you can choose which filament color to go through based on your preferences.
In the early stage of Senior Design 2 next semester, we'll finish working on the light fixture with a single light color. And we'll embark on a variety of color lights, either with coloring the epoxy resin or having glass colored, or we'll also use colored LEDs. We'll also embark on implementing smart control over wireless connection using smartphones, and we also implementing for convenience of charging a stackable base, whereby we can disassemble the glass top from the base and stack them for charging for convenience, and proximity sensor for power consumption, to control power consumption when the audience are not there, especially when it's used in restaurants, down the tables, when it can power itself off.
In conclusion, we hope to produce a viable, marketable product, and we'd like to thank our mentors, Dr. Ian DeFranco and Dr. Dale McDonald, and our sponsors, Mr. and Mrs. Brewster Waddell. Thank you.
All right. Let's thank them now. Before we start the question, I have one question. You are a special team, meaning that it's not just the five of you. You have a team from ATEC. As you can see there are additional team members that are not here. Maybe you guys want to comment about your experience with that?
Yeah,
explain what it is first of all, and then
we've been working with.
Not everybody might be familiar with what ATEC is.
So we worked with ATEC, two students from ATEC, Arts and Technology, who actually helped us with the outer aesthetics. They actually designed the CAD modeling you're seeing right here. So in collaboration, we're mainly doing the engineering stuff and implementing it into what they want, the bigger picture stuff. But as far as minute details, we're really going into that to make sure the aesthetics match the original's philosophy.
To add on that, also the Aztec are helping us with the material, like the glasses, the material for the base as the cover, but the engineering part of it, the sockets, all is our work. They're helping us with the smart, the beautiful outlook that you see.
All right, and now opening to other questions.
And your goal, one of your goals is to come up with a replacement of a valve.
It's not only to replace it.
Alarm that is working. That's
We
what-
want to modernize it. For an engineering standpoint, it's not really that hard. We can do the calculations for the LEDs and all that kind of stuff. We can do the programming for the microprocessor. So it's really an aesthetic part there. But he wants to modernize it so it's low power, it has more features, and then ultimately he'd like to sell it on the commercial market.
And to add on to that, we're really focusing on something that's reliable and durable and expands upon those features that were lacking in the original's design.
Have you done any type of review on what the market was with the original? And would you be able to provide that for that market?
Well, our sponsors made it clear to us that the product wasn't sellable in the market because it was always fragile in packaging, in shipping, and also the filament, the lamp always burned out very quick. The glass started to darken out and it burns out. That's why we hope to using LEDs with low power consumption. And this is also meant to be user-friendly with even little children. Holding that should not burn them, but that heats up very fast with the filament and nobody can easily pick it out. With LEDs, it will stay low heat dissipation will be minimized.
And to add to that, our sponsor also made it clear that we'll be marketing this to a retail sense, like to establishments such as restaurants, which features such as the stackable base will be good to charge multiple at once. And also we will be marketing an adapted version to the user just for someone's home.
I've never heard of it before. What is this used for? To light up your table when you're eating?
Yeah, it's a
or
light
what?
fixture. It was originally it was an art design that the Waddell created back in the 1970s. It was very artistically acclaimed in the art communities. It's at the Museum of Arts currently right now. It was featured in the Louvre. So it was just an art. It was an art fixture. It's like a light / art fixture that you could interact with. But his son, Bruce Waddell, believes that it could be marketable to the consumer marketplace, and that's what we're looking to do.
And we'll actually have it at our station, the original, so
Yeah,
you can look
yeah,
at
you
it.
This is the original.
Yeah.
Sorry for the non-technical question. Do you have like a target price in mind?
Yes, sir. Currently, the old style models are selling around $3,000, so it's not something that's really common. We're trying to get it down to around $30 or less, to be honest. Now, once we start actually getting our
retail, $30 cost of materials or retail.
cost of materials,
So
Yeah.
more like $100 probably.
Yes.
Yeah.
Yes, sir, but that'll be up to the
sponsor.
sponsor or the manufacturer ultimately.
All right, let's thank the team.